The sky looks perfectly calm, but in seconds, your aircraft could be fighting a violent, invisible force. This is Clear Air Turbulence, or CAT, a phenomenon that no human eye can see and standard radar often misses. While most of us associate rough air with dark storm clouds or heavy rain, some of the most dangerous encounters happen when the horizon is completely clear. Today, we are going inside the cockpit to see how modern pilots are using cutting-edge Lidar technology to detect these hidden atmospheric shears before they ever strike. Aviation experts often refer to clear air turbulence as the ghost in the blue. On a typical flight, pilots rely on onboard weather radar to navigate around danger, but traditional radar has a major blind spot. It requires moisture or particles like raindrops or ice crystals to bounce signals back to the aircraft. Because CAT occurs in air that contains no moisture, it remains essentially invisible to the tools that have guided aviation for decades. This ghost is becoming more common and more aggressive. As of 2026, we are seeing a significant rise in the frequency of severe CAT events. This is largely due to intensified jet stream patterns that create more frequent and violent interactions between different layers of the atmosphere. This isn't just a minor bump, it is a violent reality of vertical wind shear that can catch even the most experienced crews off guard. To understand why the air suddenly turns into a roller coaster, we have to look at the physics of chaos. The primary culprit is something known as Kelvin-Helmholtz instability. Imagine two layers of air stacked on top of each other, moving at different speeds. As the faster layer slides over the slower one, it creates invisible breaking waves in the atmosphere. These are not just ripples, they are chaotic fluid dynamics that turn a smooth flight path into a high-intensity structural stress test. When an aircraft flies into one of these invisible waves, there is a sudden loss of lift. This happens because the air flowing over the wings, the very thing that keeps the plane airborne, instantly changes speed or direction. This is the transition from theoretical physics to a terrifying reality in the cockpit. So, how do you fight what you cannot see? The answer is laser-focused detection. Modern 2026 flight decks are now being equipped with ultraviolet Doppler Lidar systems. Unlike radar, which uses radio waves, Lidar, light detection and ranging, pulses light into the sky. These ultraviolet pulses are so sensitive they can track the movement of individual molecules in what appears to be empty space. By measuring how these molecules move, the system can see the wind shear miles ahead of the aircraft. This data is then integrated into a visual 3D synthetic vision overlay for the pilots. Instead of flying blindly into a ghost, the crew sees a digital map of the turbulence ahead. Even more impressively, these laser returns allow the aircraft's fly-by-wire systems to react in milliseconds. The plane actually begins to prep its airframe and control surfaces for the impact before the passengers feel the first jolt. But individual sensors are only half the story. We are now entering the era of the predictive neural net. Aviation has moved away from the days of manual captain reports, where one captain would radio another to say the air was choppy over a certain waypoint. Today, we use crowdsourced turbulence data from thousands of aircraft simultaneously to create a real-time global live-in map of the atmosphere. This data is fed into automated AI forecasting systems that can predict microbursts of CAT with incredible precision. This has led to a major shift in how we fly: proactive routing. Instead of reacting to turbulence as it happens, the aircraft's computer can autonomously choose the path of least resistance, steering the plane through the smoothest possible air. The future of stability is even radical. Engineers are developing new wing morphing technologies. These wings can change their shape and contour in real time, reacting to atmospheric changes faster than a human nervous system ever could. What this means for you, the passenger, is a fundamental shift in safety. Your protection is no longer dependent on a pilot's eyesight or gut feeling. Instead, you are flying inside a sophisticated sensor mesh that monitors every molecule of air around the fuselage. The goal of all this technology is simple: to make rough air a relic of the past. By dissecting the chaotic fluid dynamics of the sky and using light to hunt the invisible, we are neutralizing one of aviation's oldest and most elusive threats. The next time you look out of an airplane window at a clear blue horizon, remember that while you might not see the chaos hidden in the air, the aircraft certainly does. Safety today relies on sophisticated detection, ensuring that even the most violent atmospheric shears are caught before they can ever disturb your flight.